Hello guys, welcome back to another video. I have told that I will be explaining about kinetic energy. So now I am back with the topic kinetic energy. So without wasting time, let's get in. So first, let us see what is energy. So the capacity of a body to do work is called as energy of the body, and its unit is joules, and 1 kg, that is 1 kilojoule, is equal to 1000 joules. So let us see what is the forms of energy. The various forms of energy are potential energy, kinetic energy, heat energy, chemical energy, electric energy, and light energy. So let us see what is kinetic energy. The energy possessed by a body due to its motion is known as kinetic energy. In simple way, you can tell it as that. Okay. So if they ask in 1 mark, you can write it like this, I think. So if they ask it like a long question, you have to write it a bit long. So kinetic means movement. So when stored energy is used up, it is making things to move or happen. The faster the object moves, the more kinetic energy will be produced. And the greater the mass and the speed of an object, the more kinetic energy will be produced. So these are the examples of kinetic energy. You can see they're like meteors, walking, falling, throwing a ball, and flying an aeroplane. So these and all produce kinetic energy. These are the type examples of kinetic energy. So next we can see the derivation of the kinetic energy. So like we know that we know kinetic energy and energy, and we say that kinetic energy of a body moving with a certain velocity is equal to the work done on it to make it achieve that velocity, to achieve the velocity. But how much do you guys know how much energy is possessed on that, uh, on that like anybody know who, do you know that how much energy is produced? So that's what we are going to see in next slide. So guys, now you can see here the how the work is being how the work formula, that half mv square you have, like you'll use it, no, half mv square, you will be using that formula. But let me tell you how that formula is being calculated, simplified, and it has come. So now what means, first we'll take it as w is equal to f into s, that work is equal to f into displacement. So that is what w is equal to f into s, and we'll take second equation as f is equal to m into a, that is mass into acceleration. So we have to calculate the velocity applied. So using third equation of motion, third equation of motion, that is w v square minus u square is equal to 2as. So here displacement is equal to, so what we get is the v square minus u square by 2a. So what happens means the v square minus u square goes to the RHS, and the s goes to the LHS, so it becomes divide. So we get it as v square minus u square by 2a. And the from equation 1 and 2, which I told the previous two equation, from the 1 and 2 equation, we take it now, we use it now. So we can write work done by force, that is w is equal to f into s. So we can write it as equal to ma into v square minus u square by 2a. So what happens means, here both a get cancelled, and we get it as m into v square minus u square by 2. So when the 2 goes to the LHS, we get m by 2 into v square minus u square. So now then it becomes half m into v square minus u square, So we know initial velocity is 0, so that is u square is equal to 0, and half mv into v square minus 0 square. So we get the, now we got the w value as half mv square. So okay guys, so now I hope you have enjoyed enjoyed this topic which I have explained now. You maybe it may be so short, but this much. This is the how we. Well, this is the explanation of kinetic energy, and so this much only I have. So I hope it may help you a lot, and maybe it will help you in the exam. So until then, see you in the next video. Bye bye. Take care.